Taranbir Singh. My student ID is 9913475519. The fundamental reason for the investigation was to discover how the material acts under the hot and cold properties. We need to discover the diverse mechanical properties of the steel. After the investigation, we can say that the hot material extends more than the chilly material. The objective of this experiment was to recognize the working of UTS tester and to compare the test results of the annealed worked metal and hot metal and demonstrate that how the chilled worked metal's tensile strength is different from the hot worked metal. Moreover, this investigation also performed to know about the benefits of annealing. That's all for the objective.
My name is Singh Toor and my student ID is 9913390033. And in this experiment I'm going to describe you some of the apparatus which we need in this experiment. First of all, we need UTS tester with the computer attached to it, which will automatically create the graph. Then next we need electric furnace for heating purposes up to 950 degrees Celsius. Then knife edge extensiometer, then plier to cut the head of the materials, then material bicycle stalk, and then ruler for measurements and vernier caliper to know the extension.
My name is Raman and my ID number is 9913494415. I'm going to tell about the procedure. We took a cycle spoke which is already cold worked and we cut that into two halves. The head of the spoke was also removed with the help of the plier. One of the part is put on the UTS tester and the other part was put in the furnace which is already set at 950 degrees centigrade. The other part was put in the furnace for about 30 minutes. The first part we put on the UTS tester. It was then the diameter of the spoke is taken. With the help of the datum program, a run is climbed or down course to load the example. And then we use the knife edge extensometer which was utilized to pinch on example operating at a profit region which has been painted on the two sides of the example. After that, we check the force, extension and position that it has been made to zero. The extensometer was uprooted when the screen popped up. The vernier caliper was utilized to measure the length which has been increased after the spokes has been cracked, and the chart of the graph stress strain curve has been made on the computer and it has been taken. Now the other part which has been put in the furnace for 950 degrees centigrade, it has been taken after 30 minutes and with very care. The part has been taken out from the furnace and it is kept on the ceramic tile for about 10 to 15 minutes to cool down because it's too hot. The same steps has been repeated with this hot item. And the readings of stress strain curve graph has been taken, and in the end the graph of both the spokes has been compared.
My name is Sukhman and my student ID number is 9913457769, and I am going to do the theory of the lab cold working and annealing of steel. In this, the basic aim behind the examination states that the steel has been cool finished at a higher quality and lower malleability than the standard part of steel. This methodology is respectable, less cost, and then the fully reinforcing resulting to there is not included expense controlled furnace cooling. It is in like manner can diminish the grain structure of the metals. Rolling is the procedure which passes metal through rollers at temperature under its recrystallized temperature. This assembles the yield quality and hardness of the metal. Normalizing is a technique of bringing the temperature to up to abundance of 60 degrees Celsius. It is held at the temperature to totally change over the structure and therefore evacuated structure the furnace and cooled at room temperature under general conventions.
Hello, my name is Singh and my student ID number is 991349786 and now I am going to talk about the rest of the theory. The essential qualification in the middle of tempering and normalizing is that totally tempered parts are uniform in fragile quality all through the entire part, since the entire part is displayed to the controlled furnace cooling. This is completed by bringing distortion into the precious stone structure of the metal, making a set microstructure which averts further slip. This results in a grain structure of fine perlite with abundance of ferrite or cementite. The ensuing material is fragile. The level of non-abrasiveness depends upon the true and constant states of cooling. That's all about the theory part.
My name is Singh. My student ID is 991349422. I'm going to talk about the discussion of this experiment. From the above calculation, we can conclude the final results of the samples. The annealed sample was stretched before it get breaks, which is clear that this sample has softening properties as well as high ductility over the cold work sample. The cold work samples graph increased at first but had a sudden fall, showed that it has a less ductility than the annealed sample. It is due to the phenomena that when the material gets heated, the grains adjust to more stable form, therefore it becomes more ductile and softened. If we talk about the problems in this experiment, we faced problem in the hot working process because it was the process to put the given sample of material in the 950-degree exposure for half an hour, because it was the minimum requirement for the sample for the hot working. In the wake of leading this test, it is observed that the frosty worked steel is extremely solid yet weak. Then again, the standardized example demonstrated more pliability and the flexibility, however less quality and hardness. Both properties might be helpful for specific application eventually. For the error examination, we can say that in our trial it was just about same as the gauges of the hot and the cold material. After the investigation, we can say that we had a mistake of 20%. It may be due to the human or instrumental error. However, we can kill it in the wake of dealing with the methodology, timing and the material.
Hi, my name is Kamaljit Singh. My student ID is 991272590. I'm gonna give you the conclusion. From this lab, we can reason that the hot material can more extend or have more broadening than the icy material. Hot materials have less elastic than the cool material. The centrality of this investigation is that we can utilize this system to use and look at the elastic properties of the frosty and hot material and separate them. For genuine utilization, we can utilize this strategy within the adornment shop. They develop structurally sound rings and other wearable questions that oblige a great deal more sturdiness by using the material. Discussion and conclusion. As we analyze both the material, the rigidity of cold work material is twofold that of annealed metal. It demonstrates that the frosty worked metal opposes more compared than annealed metal and is additionally having maximum yield quality. Thank you very much.
Thank you.